I'm Daniel Berckmans. I'm working for 35 years at the Catholic University of Leuven in Belgium. We focused on real-time monitoring of living organisms, individual living organisms. My presentation is all about real-time monitoring of livestock. So pigs, chicken, cows, whatever in the livestock sector we have. What I think for the future about this technology, that is that I think it will really be a game changer, because it has a huge impact on all stakeholders in the sector and also the consumers. First of all, many thanks to Ceva for the opportunity to speak. At this moment in research, it's extremely interesting to interact with a company that is busy with innovation and is embracing innovation, testing technical solutions in the field. That's what we need. We don't need more technology. The moment is there to create value with the technology we have. Okay, first I will say something about the team, because they do the work. Then what is precision livestock farming? Then I will say something on what is possible already today, that you can see what's going on. Then I will indeed make the claim that it will be a brave new world, something on big data, business models, and finally conclusions. The Catholic University of Leuven is a very old one. It started in 1425. We have over 56,000 students, and in total there's about 18,000 people working at university if we include the university hospital. Our research team is much smaller, but for 35 years we could have always between 25 to 30 PhD students continuously, all of them focused on algorithms. But the most important part here is the last sentence. It's about collaboration. We have 48 written contracts with teams in the world that goes from Brazil to China, because today it's about collaboration. The time of Einstein, where somebody behind a table was just thinking and doing it himself, that's over. Now it's about being fast, about collaborating. Okay, I don't have to explain the big challenges, but I want to repeat a few things because it's quite important. So this year, there will be 65 billion animals slaughtered for food production. That is a huge market. And because that market is so big, it will attract other players into it. It is a little bit like the automotive, a big market, but suddenly a new company pops up, like for instance Tesla, and they shake the tree. That might happen in this world. In this big market, it is unthinkable that companies like Google or Microsoft or Alibaba will not come. So we better are fast. Now we know all that the worldwide demand for animal products will increase with 75%. That is huge. And I don't think that we want to increase the number of animals we have to slaughter with 75%. So that shows that we need to produce more animal product with less animals, with less feed, less manure, less emission. Okay, the number one reason to apply precision livestock farming is health. It's all about protecting ourselves, safe food, but also disease transfer. Health is in the middle of it. A lot of people, they think, what is Europe busy with animal welfare? Why is it important? Well, animal welfare is in the middle of this process of efficiency and health, because all the metabolic energy which the animal is losing in stress is not available for production, is not available for the immune system. It's even worse. A negatively stressed animal is depressing the immune system. So animal welfare is not only important from ethical viewpoint, it is in the key of the process, trying to be more efficient. And of course, in that way, it relates to environment. What I mean with social importance, well, it's a very strange world where we produce food in a very cheap way. But the farmers are not respected. The farmer is pushed in the corner. It cannot be the objective. that if there is a problem like the BSE crisis, that over 40 farmers commit suicide. Also, what we see is that a lot of young people are not attracted to the sector because it has this negative image. But I think it's incredible that we don't respect farmers and they lose confidence themselves. So it's very important that we bring new technology, that we bring new people into this field, and that we help farmers, because it's a serious challenge to make your living into this world of the livestock sector. Okay, economic importance. Maybe Europe will not export meat, but we might export knowledge. Everybody has his place. In the bulk, cheap meat, South America, China, Asia is more competitive. We will have to do different things in Europe. What is precision livestock farming? Well, it's a tool for management. I will come back to the word tool. Management of livestock by continuous, automated, real-time monitoring. So every second you follow the animals, and you monitor them for welfare and health, that goes together, production, reproduction, and environmental impact. And there is a huge opportunity of many technologies. The spread of technology is added every day, but there is so much that we must be able to do something with it. As a matter of fact, we started in '91. We never were thinking that it would go. That was a purely scientific interest. We started on insects. In '93, we had the first PhD, 3D image analysis on fattening pigs, a lot of work on mussels, larvae, chicken. In between 2001 and 2002, we invented in some way that name, precision livestock farming, and in 2003, we started with the first conferences. And it went much further than what we show in this thing. There is a serious international interest. This year, there will be the 9th European Conference on Precision Livestock Farming. The first in China was 2 years ago, the first in South America 2 years, the first in America last year. So there is a big interest in it. Okay, let me show some examples. As I said, there is not a single project we do on our own. My research team is people behind the computer. We make agreements to get data, to get labeling, that is to understand what happened in the data. And we share all the results. That means publications, patents, royalties on products, and even shares in spin-offs. So we share it in an equal way. As I said, it's about collaboration. This project was done in collaboration with University of Ghent, Fancom in the Netherlands, and Agrifim. Okay, we wanted to weight animals in an easy way, because for many processes in the livestock sector, this is a very important output. Farmers are paid by weight and quality, and if we can measure weight, it's much more interesting to control the process. Okay, here you see, so the input is feed amount, feed composition, but we were interested in weight. If you measure a pig, the weight of a pig, and you do it in a manual way, and you see there is feed supply and there is weight, it's very easy. It seems to be a straightforward relationship. Now, if we take a few pigs, the thing looks totally different. Now you see some pigs, they don't eat more, but they grow much less, or they eat more, but they also grow much more. And you see, it is not that easy. Living organisms, animals and humans, are individually different. They are very complex. They are time varying. That makes it challenging. So that is what we get. The real-time monitoring with a camera is that we calculate numbers on a top view image of a camera, and we try to translate it to pigs. And you see, for an individual pig, it is quite accurately if you compare the camera weight by the hand weighing. By the way, to measure a pig by hand is not that easy. If you measure it 10 times a day, 10 times a day, the weight is different, because the pig is eating, is producing feces, so it's not an easy thing. But hand weighing is the most accurate we have so far, and you see that it can go. Now, how does it work? The top view camera is checking every second, is there a pig in a standardized position that we can put this function that is for that pig, that we can put a function on it. because all animals are individually different, the algorithm has to adapt. So with this technique, we have about 4,000 hits a day in a pen with 10 to 15 pigs. And we collect all the data, and the farmer can see the weight of his pigs. It's not yet accurate enough. The idea to use a camera for pig weighing is not ours. It started 30 years ago in Silso Research Institute in United Kingdom by a researcher called Paddy Schofield. The only thing we did is to make it dynamic, because he did it once a day, we do it continuously. Another process that can cost money to the farmer is aggression. It is normal if you have a new group of pigs that there is aggression for ranking, we can live with that, but we don't want the level of aggression that is costing money to the farmer. This was developed with the Tierhochschule in Hanover, with University of Milano and a company, Fancom. This is the type of aggression we talk about. So you see, there is always a lot of things going on, but at some level, this aggression goes to the level where we say, okay, that will give damage to the pigs. We don't want that. This is what we want to stop. How do we, first we have to detect it, and then we have to stop it. Now, to stop it, we trained piglets before weaning by giving a sound signal, and we give a sweet. So they connect in 3 days. Sound means sweet. So later, when they are fighting, we use the sound to stop the fight. There is 7 levels of aggression. Once they go above level 5, we can't stop anymore. It is like humans. At some level, that you have to pull them apart to stop it. We know that aggression takes money, and we try to solve it. All the image software that we developed for 30 years now is top view. Why? Because top view is easy to be implemented in the field. Because if you do it from side, the background is never stable. So it's easy to detect the animal from background, because the background is always the same. It's not changing. Okay, so what we did in this case, aggression is monitored by observers that can be on the scene. We call that labeling, because we need to know, to make an algorithm, you need to know when can you detect the first sign that aggression will come. Because the idea is that the algorithm is fast, that we can prevent it happening. We want to predict what is coming. And so labelers, they have a hell of a job, because if you have 24 hours of video and you want to label every image, and there is 25 images per second, well, that is about 3 man-months work. So that's where the contracts are with other research team. We provide the money that and we pay them to do the labeling. And that is often groups of girls, PhDs, who are like, we have a big group in Milano University, there's a group in Brazil, so that is how it works. On average, we spend 70% of our budget to all the people around us who do this type of work, where we only do the algorithm. Okay, the labeling can go with a tool, so the video is running, and like in this case, there is several functions. We want to be labeled, there is no aggression, they are fighting, it starts, there is many things. They just push the button when they see that, and then there is this red dot where all these activities are labeled, feeding, drinking, etc. And that is what we use for image files or sound files to make the algorithms. Okay, this is 3 different ways to detect aggression. That is the original image, top left. Top right is a very calculation-intensive algorithm. It is following the movement of each individual pig. We played with it, conclusion, too expensive, because in a farm you cannot afford. It must be very cheap. This is a much better technique. Here we follow the shadow of the movement, and that type of movement is predicting whether the fight will go yes or no. But the real interesting thing is the right bottom, where you see the color. We call that the feature variable. It took us 3 years, and what is a feature variable? It's a very simple variable that contains the information. And in this case, That is the distance between the back of the pig and the camera. And when they start fighting, they jump up, and that simple variable is changing. It is measured by a simple Kinect camera. This feature variable, that's the big secret of all the algorithms. I will give you another example. Living organisms are individually different, very complex, but also time-varying and dynamic. What means time-varying? If you do something to them, every time they might respond in a different way. Let's assume that now I go to the table, I take that glass and I just throw it to the wall. You will always maybe be a little bit surprised. And I pretend this is absolutely normal. And 5 minutes later, I take that bottle, I also throw it away. These 5 minutes later, you already respond in a totally different way. You know I'm a little bit crazy. Why? You adapt. That is exactly what living organisms do to survive, to function. They adapt to the environment. It makes it very hard to predict what living organisms are doing. You have to do it in real time, every second. That's how it works. But you all use feature variables. Let me give you, I think, a convincing example. My wife is also complex, individually different, time-varying, very hard to predict, and dynamic. But for my own sake, I have trained myself to read her mental status by just looking to the face, which is amazing. You all do that with your partner, of your friends. The whole complexity of that mental behavior and the conscious part, the unconscious part, you read it by just a few variables. We made a computer program to do it. It's not complex. So that shows it's not about complexity, it's about continuous monitoring of a feature variable. And whether that feature variable is image or sound or something else doesn't matter. You monitor continuously. The dog is better in predicting what you do than you can predict what the dog will do. Why? Because he's constantly looking what is the boss doing. And when the car comes home, he already knows, oh, it's him or her or the children. He recognized the all sound. So you don't need to measure 35 things. You measure one thing, but continuously, day and night. Yeah, that's how it works. Okay, let's go on. So these were the different techniques. Another very interesting one related to Ceva for sure, and Philippe showed already a very interesting results, and that is what we like to see, that the companies test technology and that it is not tested by us. So we have started, let me see, in 2003 I started the European Commission for Precision Livestock Farming. They organize every 2 years the European Conference of PLF. This year, that will be in August, last week of August, in Cork. If you want to get the information, search for ECPLF, European Conference Precision Livestock Farming 2019. That is the 9th here, and last year the first in USA. It says something about where we are in intensity of doing agriculture and livestock. This technology was developed by University of Milan SoundTalks, the spin-off company that we started, and Fancom. The idea was simple. We asked veterinarians 20 years ago, what are you looking for when you enter a pig house? Some of them said, yeah, I'm looking, others are smelling. Most of them said, I first come in, the pigs are scared, they see this is not a farmer, but after a minute they have to breathe and they start coughing and I count coughs. We learned to listen to the expert. We did another thing, I will come to that later, where we learned to listen to farmers. Okay, so we started to first see whether we can select a cough from the other sound. That was very embarrassing because the pigs in the lab didn't want to cough. That took us a year to make them cough with a powder of citric acid. Once we had coughs of healthy pigs, we infected them on 150 pigs, and we could see, don't worry about the numbers, the only thing that matters is the orange one. We could pick up 86% of the coughs. That is laboratory scale. To bring it to the field is still a huge challenge. The laboratory part is interesting, is the easy part. That it's about creativity and doing science. But then it has to go to the field. Now, SoundTalks, this was the result. We tested the technology in a 4-year European project. We give PLF technology to 20 farmers, milking cow, fattening pigs and broilers. And here you see the axis in the x-axis is always time. It's about dynamics. And you see the pigs came in. This is the calf index, and they were sick. It was a blind test for the farmer. He didn't know that we were monitoring. And that we had already those results, and you could see where the animals were treated. We wanted to know what is the time difference in practice. We don't blame the farmer. He cannot just stay there day and night. There was a second infection. Animals were treated, and the third infection was not picked up. I don't think this farmer could make money, but we discovered that up from 2 to 12 days before the farmer picks it up, the technology can pick it up because it's there every second day and night. Here you see when the calf index is high, the feed delivery is not going because they don't eat. They stop to eat, and so the trough is filled up, so the production losses will be there. And the idea is that there goes a signal to the farmer on his smartphone. Now, SoundTalks, they bring a solution which goes from continuous monitoring over the smartphone to the computer. And you can see it's a struggle to get hardware. This was the first system that was sold. I think they did sell over 500 systems. That was the new system, where you see a green light means no infections. As you know better than me, there is always something, but the threshold is individually different for each pig house. That's a baseline, and is the deviation from it. This was the wearable system, or the portable system better, for veterinarians. That was in the field, and this is the new system. So they have now a first batch of 600 of those. I think most of them are sold already, and that will go, they are testing it now in livestock houses, and that will go for the first year now in 2019. They are working day and night to get it done. What is funny is that 1 year ago, there was 3 people in the company. Now they have 18 people because suddenly there is interest. This system does not only monitor sound with the algorithm, it also has a temperature sensor, relative humidity, and the whole data transmission is fully automated. So there is, what is new is the business model. So you get this thing, you give power, and all the rest will go automatically. So you can also go to a computer, to an app, and on your smartphone to get information on where you are, what the evolvement is of this respiratory index that you get in the system. Okay, let me give some other examples. On the top left, in milk production, one of the biggest problems is cow lameness. About 25 to 30% of all cows, they are faced with cow lameness. So that means that or the farmer is noticing it in time, and when there is a level 1, which means there is a first sign of a problem, level 5 means, okay, the cow will be slaughtered because it went too far. We had 3,000 videos where an expert was scoring cows in a farm with 5,000 cows every week. And we needed labeling on the videos. In this case, we had 3 cameras, a top view camera, side view camera, a camera that was on the hoof, and we tested 13 different feature variables. That is like the step length, the symmetry between left and right, the step overlap, whether the back leg goes further or not, the touch angle, how the hoof is touching, the release angle, the contact time, the swing time. There was one farmer who said, I just looked to the back arch. How is the back arched? Yeah, and we are engineers. It took us also years to understand it. Finally, we made this dynamic model. Every time the cow walks away from the milking robot, she is scored. It just takes 1 step with each leg. In the commercial system, we did that with a top view camera. And the feature variable indeed is the back arch. All the rest is left out. Now we will see whether that will go to the market. We transferred it, I think now more than a year ago, to one of the leading companies in milking robots to attach this. We can recognize 82% of all cows that go from a healthy cow to the first sign of lameness. And every day it is scored. Another way to monitor health, that is the amount of water which is used by the pigs. This is a top view camera that is zooming in on a pig that is approaching the drinking nipple, and the camera can see where the front end is, and when the pig is touching in the image the nipple, we calculate the time that the animal is using the drink nipple. The accuracy of the error better is 200 milliliters over 2 weeks, so it's very accurate. It was surprising that it is so accurate. It was a PhD student who said, I want to use that. With one camera above 15 pigs, we were thinking it will never work. The reference, the gold standard, was a very accurate water flow meter, but it works in a very accurate way. When pigs are infected, that is another sign that they change drinking behavior. We can also do that for eating behavior. It is not just about knowing when they eat, we want to know how much they eat. But for drinking, it is more easy to detect whether they use the drink nipple. They might still spoil the water. It's water usage, it's not water intake. Yeah. Another one is the welfare of laying hens, is this one. This very complex chicken that is reduced to 2 feature variables. We project a figure through an ellipse, through the chick in every image, 25 times per second, and we look to the variation of the length and the width of this ellipse. And when the ellipse is moving, and the chick is moving, you see the ellipse is following, the head is even not in, and we can recognize activities of the chick when you, in a synchronized way, look to the variation of those 2 variables. Now, the ethologists, they score chicken welfare on behavior. Like a chick will only scratch when it feels comfortable, when there is no enemy, then it's busy with this activity. Or it will stand on one leg and spread the wings, that's another behavior. So they have about 10 behaviors to score animal welfare. We can recognize them just by a top view camera. So as a matter of fact, we can print on the eggs a welfare score for the chick, but I'm doubting that people will give money for it. Everybody claims that animal welfare is important, but when a consumer is going to buy meat, he will buy the cheap meat. So in Belgium, the Brazilian meat is 30% cheaper than what our own farmers can do. The people, they buy the Brazilian meat. Another very important variable when it comes to process management is, of course, real feed intake, and that's the last example here. The feed intake, well, we struggled with it with microphones on the chick. We did it for people. Finally, we got a rather simple idea to put a microphone under the feeding pen. And this feeder pen is on an accurate weighing scale. And with sound analysis, let me see whether that goes. That video is not running, that's too bad. Yeah, there it goes. I don't know whether we have the sound. I don't know, we will see. Yeah, don't worry if it's not there. What does the algorithm? It is selecting all the packings where the chick is really eating. So again, the weighing scale can measure when the chick pecks one time, it measures the feed that is gone, and then the labeler has sound and image to label every. Sometimes there's particle lost, and we don't want that. We wanted to measure real feed intake. The system has an error less than 1%, so it's a very accurate system. Strange, we could not push it into a commercial product yet, which shows that many companies are not embracing innovation like Ceva is doing. So also from sound only, it's hard to listen for yourself and to say, was it now eating or not? But it was a 4 years PhD to develop the system. Because often the chick is now very hungry, they start to play and they make a lot of noise, which is not eating. Okay, thank you for the sound. Here you see the accuracy. There is an agreement with the weighing scales and the number of packings, but it's selected number of packings. And you see the R square is over 0.98, which is huge. What's also very surprising. I want to come to animal welfare monitoring. Of course, a very big thing, because a lot of people in Europe, they claim that we will eat less meat. First of all, we will see whether it happens. But what I always say is, when Europe would just stop eating animal products, meat, milk, eggs, well, that has an effect of 4% in the world. So it will not change so much the increase in the worldwide demand for animal products, which will go with 75%. But why is it so important, the stress monitoring? Because, as we said, it's all about turning a feed into production, and all the energy produced from that feed that goes in stress is lost for production and immune system. We got a question in 2006 from a soccer team, AC Milan, and the question was, can you monitor stress? It is strange. It shows what AC Milan was in those days. They were very innovative. They did here a presentation on pigs, and it's them who said, we want to use that for soccer. I had no idea. But okay, since then, we focused with them. We worked for 3 years with them. We developed a stress monitor where we had 256 experiments with the players on the pitch, and we had blood analysis on them. We measured EEG, skin conductivity, blood analysis, saliva analysis, heart rate, and respiration rate, the gold standard for stress monitoring. And we developed the technology. Today, we are much further. We started a spin-off company, Biorix, and we can monitor stress in real time when we just wear a watch, because the watches until 2 years ago were not accurate enough, but today they are. And so what it is showing on your smartphone, the algorithm runs in the watch, and on the smartphone you can see the recovery of energy during the night, that's the green part, and during the day, that was my mental energy. The brain used that energy during the day. I was focused. Energy use does not mean yet that you are stressed. You are also using energy when you win a competition, yeah, that uses metabolic energy. The other part is the part that goes in the physical component. So far, this is the only technology that can distribute between heart rate needed for movement versus heart rate needed for mental activities. And if you look to that with the recovery part, if you see the energy use and the recovery, you can calculate for 1 day which day gives you more energy than you used and vice versa. So you see orange days and green days, and what is good that in the weekend, at least now and then, a green day pops up. Okay, that's the idea of the product. All these things, you can see the real-time stress, you can all see these things in the smartphone. It goes fully automated. You just have to do this. Now, what we had a PhD that is still running, where we follow 27 patients who are in a depression or a burnout. And as you see, a burnout person never gets a green day. So this will be published this year, where we see, okay, when you have a depression of a burnout, there is no green days. Now we monitor 40 people who are in depression, day and night, and we see, can we see the evolvement of the treatment? So we start with people in a depression. Do they improve? And is this system also monitoring? Then we think, then we might do the reverse thing. A healthy person goes to the depression, and the big question is, when can we give a warning, an early warning? Okay. Now, I want to show how it is possible to use that in real time in sports. 5 years ago, a race team approached us and they said, we want to use that. I didn't understand, but we did tests and they are using it. It's a very young team. They are 5 years old and they did win the championship 3 times. It is the VLN races at the Nürburgring in Germany. It is 12 races plus a 24 hours race. They claimed a very old thing. They said racing is purely mental. You know how to drive, then the competition is mental. This graph was published in 1956 by a medical doctor, Hans Seeley. He produced over 800 publications on stress. And the statement is, if you want to perform in an optimal way, you need a certain mental focus. If you are not interested, there is not enough motivation. If you are overstressed, then your performance goes down. I can recognize that. In January, I took 250 exams. When the student walks to the table, I can see he's in the distress zone. You have to talk about something else to make him do a decent exam. Now, this figure was never, it could not be quantified. But with the stress monitor in racing, the interesting thing is every second you have a quantitative, objectively measured value for performance that is lap time or sector time. So now you can see where this racer needs to be that day to have a very small lap time. There is other dots, but we see continuously what the driver is seeing, and we can select which dot he is alone on the track, not with a competitor, not that the radio is saying you have to come in, there is a technical problem. So we have what he can see and we have radio communication, and we can talk and advise to the driver when it's necessary. This is a test in France, in Magny-Cours, where a person is trained for a Formula 1 car. And let's go through. The green zone that is monitored in real time by the system is the bar. The x-axis, again, is the time. The red dot is where we are. So you see, there is a competitor and he wants to take over. We know that he will come out of his focus zone because it's a very risky maneuver. So we in the pits see this all. We don't talk. We can see from here mentally, when he has mentally decided, I will go and take the risk. He will come out of his focus zone. It is happening now. So we know, okay, he will go. We don't talk, no reason to disturb him. The risk is gone, the stress is gone, no problem. Now he makes a classical mistake. We had to learn that over the last 4 or 5 years. Open track, dry track, no problem. He's distressing himself. So now we say he will make a mistake. Yeah, there comes the braking error. This is what we use in the races. So the race team presented last Saturday, the new team, and again. The big thing and why I'm showing this, we will bring this to the livestock sector. We will see whether we can do it, yes or no. There is no reason not to bring it to the livestock sector. And this is what I call the brave new world. This is a test on horses, where we measure exactly the same. So the horse has a breast band, it measures movement and heart rate, but you need to measure day and night, that's very important. On the left top, you see the metabolic energy that goes in the movement of the body. On the right top, you see the metabolic energy used by the brain. That's the focus component or the stress component. We trained the horse that it has to run one circle. You see, it's curious. It is not stressed. You can see that on the top right. We show some food, but it will not get it. It knows that. It always tries to catch it, but it doesn't get it. It was a master thesis. We wanted to see, can we monitor frustration? You see, the horse is not frustrated. It knows one more circle and I get food. But we don't give the food. That was the final idea. Look what happens. It goes in stress. And look to the right top graph, and we see that on the computer while the process is going. So this is physiologically based monitoring of animal welfare. It is frustration, it takes energy, you see, on the right side. That is where we go. So then we have done tests. If we stress an animal, can the algorithm detect every time we do a stressor? It took us a long search. We did find an installation in USDA, United States, where we can take blood of the animal without the animal realizing it. So there is a small tube, and every 5 minutes there is some blood pumped out, and when the animal is turning, the floor is turned, so that in the 3D reality the animal is more or less always in same position, so that the tube is not strangled. So we had a 1-week test on several animals where we stress them positive and negative and see, does the algorithm pick it up? Yes. There, the analysis of the cortisol and the adrenaline is still going to see how does that fit or not with the cortisol measurements and adrenaline. So that's our objective, to bring this to the field. Now, to say something, yes, PLF generates some data. So here you see where we measured for 3.5 years 60 production cycles for pigs and for broilers, and we had some data. We had in total 5,400 measurements. The system was going day and night. And you see we had 120 terabytes of image data, 5 million sound data. So all the people who now claim that the big data and Internet of Things that will solve it all, and artificial intelligence, who can live without artificial intelligence? I wish them good luck. I don't believe in it. It has no meaning to send all this data higher up. You need to send up relevant information. Like an image, that's another project, I did not explain that one, but you see one image is 1,900 times about 1,000 numbers in one image, but you have 25 images per second, that is already 51 million numbers. If you do that, every 20 seconds you have to push it up. Now, that doesn't work. What is important, to transfer the data immediately to relevant information at sensor level. Otherwise, higher up you get far too many data, that's one problem. But the other one is, and from energy viewpoint, it is ridiculous. Sending data takes much more energy than calculating. So if you have a wearable, it is taking away the battery load, it will not go. If we would send the data of this every second to the smartphone, the watch will only measure for 1 hour, where now it can measure like for 12 hours. So this is the way to go. It's the same story with sound. If you have 20,000 samples, sound samples, you see you get 72 million numbers per hour. What we do is the cuff is calculated, and this is tricky. Part of it is in the cloud and part of it is in the device to prevent the copying of the software. For protection, it's better to do it in the cloud. But one number is sent, or 2 numbers, time and numbers of cuff every hour. Okay, so big data, fine. But to send them up is another problem in what the big data has to face. If you have very accurate data and you mix them now with other data that are less accurate, unfortunately the whole data base becomes inaccurate. And how do you know the accuracy? That's another problem. If you analyze the big pile of data, we had a problem with the cow monitor, the lameness monitor. We took so many videos, we paid people to take and score 3,000 videos. We never had the money to pay the researchers to analyze all of them. We only analyzed 30% and the algorithm did it. So it's very tricky. Another problem is when you pile up many data in data mining, often it goes to the standard deviation and the average of a population. That's not what we talk about. Animals are individually different. So that's a totally different thing. So I'm not so optimistic as many people say. Another thing is like autonomous driving in cars. Well, they can spend billions in it. I'm not interested. I want to drive my car myself. So that's what they think. And it will take another 20 years before every car will drive everywhere in the world in an autonomous way. Talk to the leaders of the company, they all know it. But they need many gadgets to be in the market. I think that the real thing is about management. and about prediction, about process control. Now, the other point is the discussion on who owns the data. I want to say once more, I've heard the question so often. The data, my data on my body are owned by me and nobody else. The data of animals are owned by the owner, be it the farmer or the company in contract farmer. I think it is quite arrogant to say that you own the data or somebody. I know there was in court a case in the United States where the company said, because my machine goes over the crop, the data are mine. Because without my machine, there is no data. I would say without crop, there is for sure no data. So I don't understand. The other question is, how do you share the information? That's a different question. The value comes from the information. And what I say every time, don't worry, the farmers will be smart enough to negotiate. If you don't give a fair share to the farmers, you won't get the data. He will sell them to somebody else. And that is what I mean with collaboration. We have to collaborate to make it go. Okay, the other big question is, what is the business model? The consumer needs to pay. At the end, the consumer will pay. Yeah. It's not the polluter that is paying. That is untrue. Everybody claims it. No, it's the consumer who pays. It's the end user who has to pay. But imagine the technology provider gives to the farmer for free the technology. We think one microphone and one camera has to do it all, or one sensor, but not too much technology, because you don't need to measure too many variables. It's ridiculous. Now, all the others, the retailer, the breeding company, the feeder company, the pharma company, they all can have a benefit. That means they have to give part of the money they make to maintain the system and to pay the farmer. The vet will pay the farmer will pay the vet. He doesn't realize that the vet is now paying part for the system. But the vet doesn't need the same input anymore. Less visits, he gets predictions, he gets quantitative reports, like Philippe was showing, extremely interesting, an immediate report to see how good it is going. He can do more customers with less time. That's how we have to balance that it's a fair system, okay? I'm also convinced that this will really have an impact on all stakeholders in the livestock sector. There is technology that goes to the animal, the farmer, and the veterinarian. That's a very important order. If there is no animal, we don't need the rest. If there is no farmer, people who claim the farmer will be replaced, I don't believe it at all, and I can explain that later. A very important person is the veterinarian. Why? He is the one who comes on the farm not to sell immediately a product, but he comes because the farmer asked him to come, and he is the one who has the academic level to interpret the results of technology. Technology will replace nobody. Technology will help people to act at a higher level. I know there is many people who have a different opinion. We will see where it goes. But that means that the professional expert, like the person from Ceva or the veterinarian or whoever, they have to rethink what is their position in this world, and the company as well. The key is to manage animal welfare for health, performance, and environment. That is where we have to be busy with. And the challenge is to see how do we do that with existing technology. The technology that can make value today is technology that was developed in the past years, like I showed. We started in '91. And all the new things, well, you can invest on it, but you will not make money in the beginning. Try to make money, but with what is on the table. How am I doing with timing? Let me see. I'm almost at the end because I don't want to push this. Now, what I think will happen is we need collaboration, and that will go at high level. So I see animal and nutrition, but animal welfare health, they will find each other. They will have to work together. They will collaborate with technology partners. They will go with small SMEs. Small SMEs might be very agile in developing new technology. It could be much cheaper to buy yourself into a small company than do all the development yourself. Research will be important, but in the center are the farmers and farmers' corporations. Farmers don't understand yet that data is a new source of income. They don't get it yet, but don't worry, it will come. Farmers are smart enough. Farmers are entrepreneurs. They run their own business. A professor at university is not an entrepreneur. He is paid every month, and hopefully he can do something interesting that is useful also. But I mean, farmers are smart enough, they will discover, oh, but I will negotiate about my data, and farmers' cooperatives have a very important role to play there. Okay, let me give some conclusions. The first thing what became clear after the 4-year, €8 million European project, where we tested the technology in 20 farms spread over 12 countries, is that before the project, people were very skeptical. We also were skeptical. Will it work? It seems to be sophisticated. Because today we have this feeling, oh, everything is done by technology. Well, I have a simple challenge. Go and buy today a printer and check how long it takes you until the thing is really working. Technology is just not easy. Yeah, that's where we are. After the European project, it was clear this will go and everybody gets interested. It brings the farmer to the individual animal that needs his attention. We call that active management. It's a tool. I don't think it will replace the farmer. Why not? The process is far too complex. People ask me, look, I have another thing. If artificial intelligence is that good, why does it not predict the stock market? Because it's a too complex system. It's an open system. It's not like driving a car with a few control inputs and a desired output. It's an open system. But that's the same with a livestock house. It's a very complex system. As we did here this morning from your presentation, that there is so many things in the game, like the Watson chess computer can beat a chess player, but if that chess player is dropping his coffee over the board, the Watson doesn't know what to do. So artificial intelligence is trained for specific functions, and we can use it in that way. It is therefore a tool. There is no professional that will be replaced, no farmer, no veterinarian, no company person, no expert, I don't believe. It's the same. Half of our team is working on human application. A general practitioner, he will not be replaced. The psychologist, the sport coach, no. They use systems. It's a help, it's a support. I think that the business model is a serious thing, and this is my biggest frustration. If we want to proceed, we need real collaboration. What we have today is that in the medical specialization, my brother-in-law is a medical specialist. He looks down to the general practitioner, and the general practitioner looks down to the veterinarian. That's less important. And the veterinarian looks down to the biologist, and the biologist looks down to the engineer, like me. And the engineer looks down to somebody with a technical training. And that person looks down to the farmer. It will never work. I have met many people who had no diploma, but that was the real professionals in a process. We need real collaboration, and the arrogance of scientific disciplines among each other is a waste of time and money. Okay, I thank you for your attention.